So now in this question, what is asked? It is asked to point out the direction of the normal force that the block is going to experience in each of the cases. So you have the two cases described here. One is a case where the block is kept on a horizontal surface, and one where it is kept along an incline. So when the block is kept on the surface, if you recall what the normal contact force is. The normal contact force is the force acting between two bodies in contact in a direction perpendicular to their surfaces of contact. So in this particular case, the two bodies are the surface of the table and the block. The normal reaction that the surface is going to apply on the block is going to be perpendicular to the surfaces in contact. So that surface in contact is horizontal. So the normal force that the table is going to apply on the block would be in upward direction. In this particular case, how will it be? You might say that this is the surface, so it's going to be upwards, but this is incorrect. The surface is not like this. We have clearly stated that the normal contact force acts perpendicular to the surface in contact, and the surface is along this direction. And what is the perpendicular to this surface? It's going to be in this direction. So this is going to be the right direction for the normal contact force that the incline applies on the block. It is not going to be in the vertically upward direction. It's going to be inclined. And how much will be the angle? If you want to ask, I said that the normal force is going to make an angle of 90 degree with the surface in contact. So this angle would be 90. This angle would be 90. This is the vertical, right? The vertical would always remain straight. So this is the vertical. Vertical would make 90 degree. This is horizontal, so it will be 90. This angle, the angle of incline is theta, so this will be 90 minus theta. This whole angle is 90, so if this is 90 minus theta, this is going to be theta. So the direction if you go and check out, the normal reaction is going to make, this is theta, so from vertically opposite angle, this is also going to be theta. So in case of an incline, making an angle of theta with the horizontal, the normal contact force for any object that is kept on it will make an angle of theta. Theta, that is the angle, same as the angle of incline with the vertical direction. This is the vertical direction. It may or may not be the direction in which the normal contact force acts. The normal contact force and the vertical direction coincide when the surface is horizontal, not in case of an incline. In case of an incline, it's going to be along the direction perpendicular to the surface of incline. So in this question, we have a graph, a VT graph, from which we have to find out the acceleration, because the question says that you have to find out the force that the table would exert on the ball to bring it to rest. So this is the motion of a ball as it moves from a velocity, initial velocity of 20 meters per second to a velocity of 0 meter per second in 10 seconds. So this is a case of, what is this case? This is a case of constant acceleration. So we first have to calculate the acceleration and multiply it with the mass of the body to find out the force that the table is going to exert. So let's see how we calculate the acceleration. Acceleration is what? Acceleration is v minus u by t. The initial velocity is 20 and the final one is 0. So what will the acceleration be? 0 minus 20 divided by 10, that's minus 2 meter per second square. So the force is mass into acceleration, that's 2 grams into minus 2, that's minus 0.004 Newton. So it's going to happen in the direction opposite to the motion of the body. So it's going to be a resistive force. So this is since this is a case of retardation, the body is retarding from 20 meter per second to 0 meter per second. So it's going to be a retarding force, because the table is going to exert a retarding force on the ball to make it stop, and this would actually be the frictional force. So the frictional force is going to bring down the velocity of the ball from 20 meter per second to 0 meter per second, and the value of it would be the magnitude would be 0.004 Newton. Since it is a resistive or a retardant force, we have a negative sign here. Now this is a very interesting question. It says that there are two people who are pushing a motor car with uniform velocity along a road. The mass of the car is 1200 kgs and they are moving with uniform velocity. And it also says that anybody who is pushing the car pushes the car with equal muscular effort. So the force applied by any individual will be equal to the force applied by any other individual who is forcing the car. So it says that when initially the two people force the car of mass 1200 kg, it moves with uniform velocity. Why would it move with uniform velocity when there is an application of external force? There is, when they push the car, there will be a frictional force that is going to act on the car, which is going to stop the car from moving, and hence the car would move with uniform velocity. So let the force applied by each individual be F. So since there are two people pushing the car, the total force that will be applied on the car would be 2F. F and F. Two people will be together pushing it with 2F. There will be a frictional force that will be acting down. Let it be F. The total frictional force is acting on the body will be F. It says that the total force in the forward direction is 2F and the frictional force would be minus F. It moves with constant velocity, hence the acceleration is 0, hence the net mass into acceleration would be 0. And we observe in this case that F will be equal to 2F. Now the tires are going to be the same, so the frictional force, the kinetic friction is going to remain the same in both the cases. The second case is what? Three people now start pushing the car. So when three people push, the total force would be 3F. The same surface is in contact, so the frictional force is not going to change. But in this case it says that 3F minus F produces an acceleration of 0.2 meter per second square. So you have mass 1200 and you have acceleration of 0.2. So what is F? F is 2 capital F. So this is how much? It's 240. So F comes out to be equal to 240 Newton. So the total force is 240 Newton. So what do we have to calculate? We have to calculate the force that each person applies to push the car. So the force applied by each person is 240 Newtons, and this is what the answer is. In this particular case, you have the distance time chart for a particular motion given here, and the question asked is what conclusion can you draw about the acceleration, whether it is uniform, whether it is constant, whether it is zero, whether it is changing, increasing, decreasing, or whatever it is. Now how do we calculate that? We have the time at time t is equal to 0, the distance is 0. So initially we can assume that it is at rest. In this time span of 1 second, it moves the distance of 1 second. So what will be the velocity be? Average velocity for this duration, it will be 1 by 1, that is 1. In this particular case, again for time duration of 1 second, it moves a distance of 7. So the velocity would be 7 divided by 1, that's 7, because velocity is distance by time. So here again you have a time span of 1 second, and what is this? This is 19. So here for this particular second, in the third second, the velocity comes out to be 19. For the duration 3 to 4 seconds, what is the velocity? It's going to be the difference of 64 minus 27, which is 37. Similarly, if you go on doing it, here you have 61, you have 91, and here you have 98. So this is the velocity for each of the intervening seconds. Now to calculate the acceleration, what do? You calculate v minus u divided by time. So time span is 1, change in velocity is 1, so here the acceleration is 1. Again here it will be 7 minus 1, that's 6 divided by 1, because 2 minus 1 is 1, so the time span is 1. The change in velocity is 6, so it will be 6. Here it is going to be 12. Here it is going to be 18. Here it is going to be 24. Here it is 30. And here it is 7, or whatever it is. So the change here is 7. So this is how the acceleration is going on changing. So what you can say, it's increasing. It is increasing up to a certain time, and then finally in the last second, from the 6th to the 7th second, it is just going to be, it's going to decrease because the velocity changes from 91 to 98. So the acceleration is going to decrease in the last second. In the other intervening second, it's going to be increased. What do you infer about the force acting on the object? As the acceleration increases, the force is going to increase on the object.